So how do you form a BSS, basic service set? Again, since there is no access point, actually there could be an access point, but in this case they decided, just like everything else we have seen so far, that it's a function and any station can do that function. So WSS coordination function can be done by any station when requested by an application. So the provider is the device that stars WSS and generates the announcement. So this is the coordinator, and the coordinator could be either an OBU or RSU. Now at least you remember what is RSU. Roadside unit. OBU is the onboard unit. So either the car or the tower can start, can be a provider. And everybody else joins and they become the user. And if it stays persistent WBSS announced every sync interval, so there is a period over which the announcement is made that, okay, I have this WBSS. Non-persistent is whenever you need it, you start it and then you go away. Short-lived, announced at permission only, easy support to on-demand file download. So if you were either transmitting some files or you were receiving some files, then you will form a WBSS, see if there is a car nearby or a RSU nearby, and then you can start communicating. Server applications registered with WME with a provider service identifier, PSID. So this is similar to SSID. Service set identifier, and this is PSID. And now this is confusing because we call it WBSS, but the IDs are called PSID. Okay, provider service ID. So server applications registered with WME, but actually this is different than SSID. SSID is the name of the network, and this is like a port number. Okay, so it's like 80, 21, 23. These port numbers. So that port number really indicates what the application is. So when you want to talk to somebody, let's say you want to do the file transfer on the internet today, you will say, I want to connect to port 21. Okay? And at the other end, generally port 21 will connect to an FTP server. Alright, so that's the standard. It is quite possible that somebody has an FTP service on port 22. In that case, they will just let the people who are connecting to it that, look, you're going to connect to me, you will connect on port 22. So you send a message, I want to connect to port 22 on this computer, and you will connect to their FTP service. So there are well-known port numbers, and you don't have to use them though. Everybody knows that part, right? But the port numbers, some port numbers are well-known, at least up to 1024. This is all in 473 we teach. Up to 0 to 1024, these are standard, and they are well known. So if you want to do HTTP, you generally do on port 80, but you don't have to do port 80. You can be on port 81, some are 8181, some people are 8080. Whatever port you want to choose as a provider, you can select, right? The receivers have to, the other side has to know the same thing, so they can connect to you, right? Because it is, at least right now, not possible to say that I want to connect to HTTP server. You just have to say a number. And that number has to be known to both sides. So there is a standard number and there are non-standard numbers. The same way here. Back to this, PSID is your port number. And a WBSS is initiated when the first application registers and the provider service table is broadcast periodically. So basically, let's say an RSU, roadside unit, is providing two services. One is a best service, and second thing is, in general, they would be providing a map service or something, some kind of directory, business directory. So let's say providing two services, business directory, and what did I say? Two services they're going to provide. So they will have two numbers, and those will be announced that, okay, I am here, and here is this BSS, and you can connect to the web service, and you can connect to this business directory. And so people who want to get that information will connect to the right service. Now, before this announcement, they would form a WBSS. So as soon as the first application starts up, it tells RSU, look, I want to start a business directory, and they will start a WBSS. It start announcing that, okay, I want to provide a WBSS. Okay, and it will become a provider, and all the users will join that WBSS. There may be another WBSS which is providing some other service, and that is the provider for that service, and it may provide the same service also. It may provide a business directory service as well. But basically the user has to decide which WBSS to join and which service to join. No, they can be doing at the same time. It's just like this. Who can transmit the file? You can transmit the file, I can transmit the file. So it doesn't matter. You can do two applications at the same time. So you could be a WBSS and you could be joining other WBSS. If that's the question, right? Yeah. The thing is, it is quite possible that I'm getting my information from the roadside unit and I'm a big truck, police truck or whatever, or fire truck, and I'm announcing to the rest of the world. So I'm getting information on this side and sending it on the other side. Right?
Like the AD?
Like the AD. TBSS. Now, I've forgotten TBSS. In TBSS, actually, there were relays. And this example, the last example I gave was more like a relay example, right? But in TBSS, and the coordinator does not need to be, see, the thing is here, there are two functions, okay? First of all, there is a coordination function and there is a service function. So I'm providing some information. And so for that service, I have to coordinate, right? In wireless HD, the coordination function is totally independent. So if you're providing some service, you don't have to be coordinating. Okay, so let me give you an example. For example, if you have a DVR and a TV, DVR is providing the video, but it is not the coordinator. The coordinator could be TV. And at the same time, the same network, somebody else, let's say a remote control, is doing something. Again, it is not the coordinator. It is just going to ask the TV when to transmit. Right? So, HD, actually, the service and the coordination were totally independent. Here, as soon as the service starts, it says I need a coordinator. And it becomes the coordinator. Not the first one is, so the first service that starts makes that station become a coordinator. Right? If the second service starts on the same station, it's already a coordinator, so it doesn't have to start again. It just adds services to its announcement. Okay? Now there could be other, so it's like more like, I can imagine, it's more like stores. You go to one store, it is selling groceries and clothes. Another store is selling medical devices. They are both providers. They are both services. They are both have their own WSS. So each service needs a WSS. If the station is already providing WSS, then it's fine. If not, then it will announce. All right. When applications register their interest with their WME, now user applications do the opposite. The user says, look, I'm looking for a service like this. They tell their management unit, WME, their management entity, and WME monitors announcements to check if the provider service table of a WBSS is of interest. Somebody is trying to match. Is that this service available? Right? And when there is no active application, when the services go away, the WBSS is shut down. If nobody is providing any service, the WBSS goes down. Okay, so the main thing I think is that here the WBSS are related to the service, which was not the case so far. I mean, access point, when you put the power on, it just starts. It doesn't wait for anybody to provide any service. It's always there, 24 hours, right? In this case, whenever there is an application ready and there is something to be done, then only we start the service set. And when there is nothing to be done, service set is closed down, and there is no announcement. And I think this works equally well, and it saves some power because if there is no announcement, there is nothing to be sent out. I'm not providing any service, so the cars can just keep going by. They won't connect to me. Now, having said that, actually, I think if I had a roadside unit, I would probably provide a service called internet service. And many cars may want to connect to internet through this service. So they can always connect to 3G, 4G, whatever, right? But they can also connect through this one, which might be cheaper, through Wi-Fi, right? And if you provide a service like that, it probably will be up 24 hours. In the middle of the night, somebody comes and wants to connect to the internet, and they would be there. I mean, it could be 9 to 5 as well, but most likely it will be 24 hours. So anyway, this is all outside the scope of 802.11p. They don't decide on when you shut down, when you turn up. But basically, they allow the possibility that if you don't have any service to provide, now, how do the cars to cars communicate, right? And so that could be part of what we call, which does not require a basic service set. And so that is non-WBSS communication. So outside the context of BSS. So stations do not have a member of BSS to transmit. A Dave device can send a WSMP message to broadcast address on CSC edge. On the control channel, you can say, I want to talk to somebody. Whatever you want to say. Another Dave device can say, okay, all right, I'm ready to talk. And basically, you don't have to talk to each other, you don't need to have part of a BSS. So that is what it says, no WBSS synchronization. Timing advertisements from the providers, default parameters, values, and time stamps indicate local time, and authentication handled by hardware. So basically what that means is that when you say I want to talk, you are the provider, and you provide the timing. You say, well, the time right now is so much in my clock, and this is what I will use. Just like a beacon, you just tell them that I'm going to use what kind of modulation, what kind of all other parameters that they need, and so the receiver will receive it and then tune to those parameters. So this is basically peer-to-peer. And security, etc. is not part of this layer, it is all higher layer. OCD stations use slightly higher AIFS than WBSS parameters. Now, I don't know how many of you remember AIFS. Yeah, interframe spacing, and that was in 802.11e, right? So that is the time that you have to wait before the channel has to be idle before you can transmit, right? And so OCD stations have to wait longer. So people who are using WSS, they in some sense get some priority. They're already scheduled, they already have coordination and so on going on. If they don't speak, then you can speak. OCD stations use wildcard in the BSS ID field in the MAC frames. And the BSS ID, which is actually, this is all 11 by the way, so it is still the same frame format with 4 addresses. In some of the frames, you have BSS ID, and in the case of other, you will put the WBSS ID. Here, you will put star, asterisk, wildcard, which could very well be all ones or all zeros. I don't know which one, but basically wildcard. So I'm not part of any particular WBSS. So 11P, there are a number of companies which are making products, You generally don't see these products because these are sold directly to the car companies and they come directly built into the car if your car has a need for this. So OBU and RSUs, radios, SDR, software-defined radios, and then hardware implementation, HDL implementation. So ETM makes intellectual property. IP is there for intellectual property. Is that sometimes some companies, they don't sell any hardware, they just sell you a file, which is basically, in this case, is HDL implementation, hardware implementation of something. Okay? And then you can implement it, you can make the chip yourself. Card access engineering sells the designs, LightPoint makes the test platforms, and then there's spectrum analyzer, etc., etc. So some of these products are shown here. So GSRC is designed for short-range communications and good for city, but long-range communication is also required on highways using cellular technology. So GSRC does not really cover the whole VANET. It is only in the city that you can use it. When you get onto the highways, the distances become in miles, and the best ways are used to use the cellular towers. This requires multi-channel OBUs. And so the onboard unit will have to be able to use not only multi-channel but also multi-network, which means that they have to be able to do 3G, 4G, and Wi-Fi. That brings us to the end of this module. And so the VANETs have a very dynamic topology, very tight delay constraints, and so now we know what is V2V and V2I, right? And we know what is RSU and OBU. Now they have only 10 megahertz, and therefore everything has been squeezed down from 11A to half in the frequency domain, and therefore twice in the time domain. Okay, frequency parameters are same, and basically frequency parameter number of players is same, and therefore in the time domain everything becomes twice. And then they have 5 channels. One is the control channel, and then 4 service channels. ASTM started with SART message service protocol, and then 1609 started the MAC and the management, and then P provided the PHY, and they just basically took the 11A PHY essentially. QoS is similar to 11E, but now extended to multi-channels. This is common. This is all basically the summary of this. There is a homework, and there is a reading list,